A water fountain on the ground sprinkles water all around it. If the speed of the water coming out of the fountain is u, the total area that the fountain gets wet is okay. Total area, or I think that total area in the ground that foundation that gets wet is okay. So, in order to solve this question, let me make use of a diagram, a photograph here. Okay, so this is what we need to understand the concept that has been asked here. So what we need to primarily keep in mind is that it's given that it is coming out at the velocity u, and it is coming out with the velocity. So the option says v, so let us say it is coming out with the velocity v, and it is not specified at which angle it is being coming out, right? So the water is coming out at many possible angles. What do we mean by that? Say for instance, this is the point where the water is coming out, and it is constantly coming it is coming with a constant speed of v meter per second. Now if you observe this trajectory here, right, this trajectory here, this is coming at one angle theta, say maybe theta 1, right? And then we have another angle, say over here, let me use a different color to mark that. So we have another angle here, right, which is coming at theta 2. We have one more angle, say okay, let us make use of this tallest one, right? So we have, which covers the maximum height, that is another angle which comes like this. So we got theta 3. So there are many possible angles like that, but the maximum region, right, the maximum region where it is wet can be calculated by this side, right, this much, right? So if you mark this as theta n, which gives the max, or theta max, which gives the maximum. And if you want, you can draw even further to understand the concept. Say this much is definitely it is falling before that, so that you mark it as theta 4. So there can be many theta values, right? That's what we're trying to say. So there can be theta 1, theta 2, theta 3, theta 4, and so on. So what we need to understand is, putting this into our diagram, say see this is a sprinkler, or this is a fountain. If it is fired only at theta 1 angle, so it may come like this, right? Now this is happening not only in one direction but also in every direction. So it may fire like this too, it may fire like this too, right? And water will come the maximum at this region, right, theta 1. But what we need to understand is water is being sprinkled even beyond this. So water is being sprinkled like this also, at theta 2, at theta 2, at theta 2, sprinkling at theta 2, which means at theta 2 the water is sprinkled at even farther distance. Now what happens at theta 3? Theta 3, the distance is increased, it is coming here. When it is rotating, it will come here. So as the theta value is increasing, the region of ground which is actually covered with water, or which is actually getting wet, that also increases. But the question is, how far will the ground be wet, right? Will be wet. So we can understand that it will be wet when this value is the maximum, right? So when this value is the maximum. Now this value, when you consider this to be a projectile, right? Consider this to be a projectile, it will come like this, right? It will again make such an angle. So it will make an angle like this. It will come here, same angle here, same angle here, and if you connect the points, this is what you get. Now I'll redraw the last figure alone. So we said that this is the maximum distance that the fountain can come, the maximum distance the fountain can come, and then many such maximum distances will make a circular track like this. Okay, what we need to understand here is, this is coming as the projectile motion, which means maximum distance here actually refers to the range, or to be more precise, the range maximum. And the area represents a circle with what? Circle with the radius to be r max. Now what is the area then? The area is then equal to pi into r max square. So area is equal to pi into, what is r max? R is equal to r max when theta is equal to 45 degrees, and when theta is equal to 45 degrees, what is r is equal to? R is equal to u square by g. So we can write this as r max as u square by g. Now is it r max? No, it is r max the whole square, and therefore what we get is a is equal to pi into u raised to 4 the whole upon g square. Okay, now I think I should write it down one more step to make sure that the concept is clear. So what we can write here is, see, r is equal to u square sine 2 theta by g, right? So what is r max? R max is obtained at theta is equal to 45 degree, which means this much angle should be 45 degree. Only then the maximum distance will be equal to the range. So which is equal to u square. Sine 2 theta is 2 into 45 degree, which is sine 90. And what is sine 90? Sine 90 is 1. So this is g. So what is r max? R max you get as u square by g. And what is r max here? R max here is actually the radius of the region of ground which is getting wet. And if that is the radius, what is area is equal to? Area is equal to pi r square, which is pi into the explanation follows, which is u square by g the whole square. Well, I would say not a tricky question, but yes, definitely a conceptual one. See, what happens in JEE mains is you got 30 questions, right, in 60 minutes, which actually gives you 2 minutes per question, 2 minutes per question at an average time. So this question, if you're doing it for the first time in the hall, it takes some, it takes some time to understand the concept. Well, actually, there's nothing conceptual. I would say it is more about visualization here, right? To get this part visualized is the main task here. Once you have visualized it, then there's nothing deeply conceptual. It's all about applying the formula. So yes, some of the questions in JEE mains which are asked, which demand these kind of concepts, they are time consuming, but of course not all of them. Anyway, we'll practice more question, and our perspective will widen how to approach perspective will widen when it comes to approaching new questions, or rather questions which we have not been exposed to, but we know how to, but we can find a way out to solving them. Alright, now let's move on to the next question, which says a projectile is thrown with the initial velocity of